Hello, everyone. Today, we're diving into linear programming, a tool for making the best decisions when resources are limited. Imagine you run a bakery with two best sellers, chocolate cakes and vanilla cookies. Your goal? Maximize daily profit. But you can't bake endlessly. You have limited flour and sugar. Each cake and cookie batch uses different amounts of these ingredients, and each brings in a different profit. The big question: how many cakes and cookies should you bake to make the most money without running out of ingredients? This is a classic linear programming problem. You have a clear goal, limited resources, and choices to make. Linear programming calculates the exact mix of cakes and cookies for maximum profit. It takes the guesswork out and gives you a data-driven answer. Think of it as a recipe for the smartest possible plan. That's the power of linear programming. To solve our bakery problem, we need to know the building blocks of linear programming. First, decision variables, what you control. Here, it's the number of cakes, X, and cookie batches, Y. Next, the objective function, your main goal. For us, it's maximizing profit. Profit equals sign 10x plus 5y. Then come the constraints, your limits. For example, 1x plus 0.5y, while 10 for flour and another for sugar. You also can't bake negative amounts, so x plus 0, y are 0. When you plot these constraints, you get the feasible region, all possible combinations you can actually make. The optimal solution is the point in this region that gives the highest profit. In linear problems, this best answer is always at a corner of the feasible region. So, to recap: decision variables, objective function, constraints, feasible region, and optimal solution. These are the essential pieces of every linear programming problem. With these, you can model and solve real-world optimization puzzles. It's a simple structure, but incredibly powerful. That's how you turn a messy problem into a clear solution. Let's see what makes a problem suitable for linear programming. Not every problem can be solved with linear programming. Here's what you need. First, a clear objective, something to maximize or minimize, like profit or cost. Second, constraints. Real-world limits like time, money, or materials. Third, alternatives. Different choices to compare, represented by your decision variables. If there's only one option, you don't need linear programming. The power comes from comparing many combinations to find the best one. Finally, everything must be expressible as linear equations or inequalities. That means relationships are proportional. No weird curves or sudden jumps. If your problem checks all these boxes, linear programming can help you find the optimal solution. It's a checklist, clear goal, constraints, alternatives, and linear relationships. With these, you can model anything from a bakery to a global supply chain. That's what makes linear programming so widely useful. Now, let's look at the assumptions behind the method. Linear programming works because it makes a few key assumptions. First, proportionality: doubling your decision variable doubles its effect. No discounts or diminishing returns. Second, additivity: the total is just the sum of each part, no weird interactions. Third, divisibility: you can use fractions, like baking 2.5 cakes, even if that's not practical in real life. For whole number answers, you'd need integer programming. Finally, certainty: all numbers, profits, resources are known and fixed. In reality, things change, but linear programming gives you a solid starting point. These assumptions keep the math simple and the solutions clear. They're why linear programming is so effective for many problems. But remember, if your situation breaks these rules, you may need a different approach. Understanding these ground rules helps you know when linear programming fits. Next, let's see why it's so valuable. Why use linear programming? It helps you get the most from limited resources: money, time, materials, or labor. It turns complex allocation problems into clear, actionable plans. Decisions become data-driven, not just gut feelings. The method considers all constraints and variables at once, guaranteeing the best solution. It's versatile, used in factories, farms, airlines, diet planning, and finance. The same structure works for countless real-world problems. Building a model also reveals bottlenecks, like always running out of sugar in our bakery. That insight helps you focus on what really limits your success. Linear programming is a powerful tool for efficiency, clarity, and strategic growth. It's why so many industries rely on it. But it's not perfect. Let's look at its limitations. Linear programming isn't a cure-all. Its biggest limitation: it only works with linear relationships. Real life isn't always proportional. Bulk discounts or worker fatigue break the rules. It also assumes certainty. All numbers are fixed, but reality is full of surprises. The divisibility assumption can be impractical. You can't make half a car or hire 2.7 people. For whole number solutions, you need more complex methods like integer programming. Building a good model can be tough, especially for big organizations with lots of data. If your data is wrong, your answer will be 2. Garbage in, garbage out. Despite these limits, linear programming is still a powerful starting point. It gives you a clear, logical plan, even if you need to adjust for real-world messiness. Knowing its boundaries helps you use it wisely. For many problems, it's the best tool available. Now, let's see how it's used in the real world. The applications are everywhere. Linear programming is everywhere. Manufacturing, finance, agriculture, and healthcare. In factories, it plans what to make, where, and how much to minimize costs and meet demand. In finance, it helps build investment portfolios that balance risk and reward. Farmers use it to decide which crops to plant for maximum profit, given land, water, and labor limits. In hospitals, it schedules staff and plans treatments, like delivering the right radiation dose to cancer patients. The same math that helps a bakery maximize profit can save lives or grow wealth. It's a silent engine behind smarter decisions in every industry. Linear programming turns complex trade-offs into clear, optimal plans. That's why it's so widely used. Now let's look at a famous example in logistics. Companies like FedEx and UPS use linear programming to solve massive delivery puzzles. Every day they must deliver thousands of packages using a limited fleet, minimizing cost and time. This is the vehicle routing problem, a complex optimization challenge. The objective: minimize total cost, including fuel and wages. Decision variables: which packages go on which truck and in what order. Constraints: truck capacity, driver hours, delivery time windows, and traffic. Sophisticated software like UPS's Orion uses linear and integer programming to find the best routes. The result? Millions of miles and gallons of fuel saved every year. It's a real-world example of math making business and the environment better. That's the impact of linear programming in action. To recap, linear programming is about making the best decisions with limited resources. It translates real-world problems into mathematical models for optimal solutions. From bakeries to global corporations, it brings clarity to complexity. The key components: decision variables, objective function, constraints, feasible region, and optimal solution. This framework helps you structure and solve all kinds of challenges. While it has limits, its simplicity and power make it invaluable. Learning linear programming teaches you to optimize, allocate, and think systematically. It's a bridge between math and real-world impact, helping deliver packages, treat patients, and grow businesses. As you move forward, remember, optimization is a cornerstone of many fields. Mastering it gives you the tools to solve some of the world's toughest puzzles.